Hello everyone. Today I will cover a session on controlling robots through SSH. In this we will learn what is gazebo, what is SSH and how do they function. So just basic contents of today's slides. What is gazebo? How does it function? What is URDF? A thing required by gazebo to function. And how is URDF built or how is URDF different from other 3D model types? And a demo using Turtlebot 3. Then we will learn everything about SSH. Mostly the practical part that how does it function. So what is Gazebo? Gazebo is a powerful 3D simulation tool used for testing and developing robots. In ROS2 ecosystem, Gazebo is a 3D tool in which you can visualize your robots. Like in Blender, you build 3D models. Here you can build 3D models and provide subscriptions and publishing through the robot models and connect it from the outside environment, providing a realistic visualization. So with features like collision detection, lighting effects, and plugin support, Gazebo is widely used in the academia and industry. Okay, fine. So next, how does Gazebo function? So as Gazebo is a part of the ROS2 ecosystem, Gazebo is integrated with the ROS2 and follows its communication architecture using nodes, topics, services, and actions. At the right side, you can see a unitary robot model that is built in Gazebo. This robot model, for example, if we provided some input from the outside that you have to walk, then we have to provide the input that which joint of it will move to which angle and which display and how much displacement so that it can move accordingly, right? So by this from outside using nodes, topics, services and actions in ROS2, we can control this robot in Gazebo. We will see everything how to do it. Okay, fine. So Gazebo uses a file format of 3D simulation known as URDF, that is Unified Robot Description Format. These files bundled with ROS2 makes Gazebo a futuristic robotic simulation tool. Fine. Now, next, what is URDF? URDF is an XML based format. KML is also an XML based format, if you remember. So, URDF is similarly an XML based format that defines a robot's physical and structural properties. That I said before, you have to give which are present, which are the movable parts, which are the non movable parts, and describe the parameters like the mass of it, the collision property, is this transparent, and obviously how does it look. So used in ROS and Gazebo, URDF enables accurate kinematic and dynamic simulations. It is typically created manually or using tools like Zacro to simplify complex robot descriptions. Today we will just work with URDF but not build one that is a little bit more advanced. So why is URDF different from any file format that Blender produces or Fusion 360 produces? Okay, so it is different because unlike 3D models like STL, the file format we use for 3D printing, or OBJ, which only stored visual geometry, URDF describes a robot's structure, kinematics, and physics properties. It defines joint movements, collision detectors, and sensor placements, making it essential for robotic simulation. So, for realistic robot behavior, every information of these joints, collisions, and sensors are necessary, right? So, therefore, it has to be defined, and this format is called the URDF format. So, this is an example of the URDF format. You can click this link and go to this file. So this contains many of the URDF examples. We will just open this first one. For example, I'm seeing an example. How does a URDF look? So you can see this is a Pelican URDF example, and in this, both the STL and URDF files are provided here. It is some kind of a quad rotor. So I open this link. and then you go to this Pelican URDF file. These are all ROS nodes, I suppose. So yeah, you open this Pelican URDF link, and then in data, you will get all these XML files, which are actually URDF. So in this URDF file, you can see here is some geometry. On going further down, you can see here joints. So joints are defined here, joint name. Here are joints. These are lasers. This is a virtual laser. Something or the other is robot is related, and this is how it is defined. Fine. Now going back to our original presentation. So now we will see a demo with the help of TurtleBot 3. What is TurtleBot 3? TurtleBot 3 is a very famous example in the field of gazebo robotics or simulation and actual robotics also. So we will see how to install this, and then what can I do with it basically. Fine, I will go here and search TurtleBot 3, right? TurtleBot 3, I search, and here you can see for simulation. You will go that I want to simulate, and it will show gazebo simulation. Something you have to do is you have to first follow the PC setup instructions. You have to follow the setup instructions that I've done. So you have to open this PC setup link, and then just follow all of this. Install Gazebo, then install these nodes, these packages, which will help you to perform further experiments. And then we will be able to do something with it. We'll see what I can do. So we can do a SLAM simulation. SLAM is basically exploring an area and undefined area and creating its map. Okay, so today we are going to do this. So how to do SLAM, right? Using Gazebo. You have to first export this. So fine, I will just export this model and then launch this file. These are all after you have done the first two steps, which are Gazebo simulation setup and the PC setup, right? First PC setup, then the Gazebo simulation setup, right? And then you can see I have to launch this world. Then launch this world. So something is launching in my Gazebo world, and you can see this just spawns up in my world, right? This is a Gazebo world. It is a 3D environment in which this is my robot. It sits here. This is my robot, and this is the Gazebo world. Okay, fine. How we can do SLAM using it? Run the SLAM node. How to run it? In a separate terminal, you have to first again export the robot module, and then run this. And something called the RV spawns up. RVs is basically robot visualization. So it helps us to run that node, to run that uh, robot and move it anywhere around the map, right? And visualize the data we are gathering. So for moving it, we are going to use the teleoperation node, and we will just run a new terminal and say export and run the node. Fine. We will just run the node using these keys, and then for saving the map, you can do this. Okay. So now coming to the main part, we will see how everything happens, how everything comes together. So this is my Gazebo world. I will just minimize it a bit, and then you will see here that the robot is moving according to my keyboard, and then the data we gather will be mapped in this, right? How to do this? We will see. Fine. I'll switch to this robot and start moving this robot. So, how to move that robot? By W. We can move it forward. You can see here the robot is moving forward and the part it is scanning is being detected here, right? You can even turn right here and stop, then start moving the robot. And you can see how easy and fun this is to do. Just run your experiments and the robot does everything else. Right? And to save these areas are still unexplored. You can see the dark areas. So you have to move your robot around and then visualize all of these points, and then you will get a map, something like this. You can save the map if you run this command. So to save the map, I will just close the robot, close the teleoperation key and hit save, and it is saved successfully to LG demo map YAML. So we will see there is a map and map YAML. This is our actual node that we have created just now. So if I get, this is my map, right? These parts are still unexplored. So you can try this at home. Fine. Now the next part, SSH. Okay. For this, I have to. So moving forwards, what is SSH? So SSH is a cryptographic protocol that allows secure remote access to systems over an unsecured network. What are protocols? Protocols are rules that are defined according to which any two system or networks provide data or any transfer of information happens. For example, HTTP, TCP, these are all very famous internet file transfer protocols. Now, SSH encrypts data transmission, preventing eavesdropping and unauthorized access. SSH supports remote logins, file transfers, and command execution using authentication methods like passwords or SSH keys. If you know, Git and GitHub ecosystem also provides SSH connection to your online repository from your local system, right? Now, system administrators rely on SSH to control servers safely, execute commands remotely, and maintain cloud infrastructure. So, what we will be doing today is take this SSH connection protocol, and then from Windows, we will try to control the previous robot, or you can say ROS package that we have built for the previous session, and try to control it from the Windows to this Ubuntu 22.0 virtual machine that we have. So what does it mean? For final execution, we will try to connect our virtual box, which is a Ubuntu 22.0 VM from our Windows through SSH, and then run the ROS2 program we have built in the last session. For this, we will need to do something in the Windows domain also, host only network creation, port forwarding, and then SSH in Windows command prompt. But before that, in your Ubuntu virtual machine, you will need something known as the Open SSH server. So this is what enables SSH connection to your Ubuntu system. So we will do sudo apt install Open SSH server, and I will give my password, and you can see that it is already installed in my system. Next, we have to check that what is the status of the OpenSSH server, right? So for that, you have to do sudo systemctl status SSH. You can see this is active and running. If it was inactive or closed, we had to do sudo systemctl enable SSH now. This would open this port, but as this is already active, we will not mess with it. Now, fine. The next step is you have to see if your firewall is active, Ubuntu firewall. So we have to check the status, sudo ufw status, and it is inactive. If in case it was active, you have to do sudo ufw disable. Fine. Now, the next thing, we will use a port to connect to this SSH. You can already see here the server is listening on port 2, but to further check this, something we can do is sudo ls soft pn grep the listen ports. And in this, there should be the 22 port listed. And as you can see, the 20 port number 22 is listed here. So it is fine. But if for any reason it wouldn't be listed, one thing you have to do is sudo ufw allow SSH. So you are telling the firewall to unblock the SSH port, which is basically 22. Fine. Now all of this is configured. We will go to our Windows system and configure the outside settings that we have to do in our virtual box. So what do we have to do our virtual box? We have to create a host only network and connect it to the virtual machine. We have to port forward the virtual machine and then SSH in the Windows command prompt. So how to do it? We will see one by one. Fine. So let me show what package we are going to run today. The package that we have built in the previous session. So in the previous session, we have built this action workspace, and inside this we have a launch file. So action workspace, and inside we have two packages, custom and project LG. And inside this project LG, you can see in this launch directory, there is the final launch file, right? And we can launch it by saying this normal directory, this normal terminal, and you have to type ROS to launch project LG final launch dot file, right? And this launches, right? So we want to do this. We want to see if we don't have the access at all to this Ubuntu system, how we can do it just through Windows. Fine. Now for that, I have to do some steps regarding this virtual box connection. We have to create a host only network, port forward, then SSH in the Windows command prompt. Right. So how to do it? We'll just switch to the Windows, and so we have the Windows here, and in this we will go to the virtual box. Our virtual machine is running. We have to close it first, and then I've done the settings. I will just show you. In the network, I have three host only networks, 1, 2, and 3. And in this virtual machine, I have connected in the adapter 2, the host only network adapter 2, right? In the adapter 1, there is normal NAT. Fine. Now you go to the settings of this virtual machine, and inside network, you will see I have port forwarded the NAT connection. The adapter 2 connection does not have any option of port forwarding as it is host only adapter. But in the NAT adapter, you can port forward, and I have named it SSH. The protocol is TCP by default. The host port must be 4 times 2, and the guest port is 22. So how can you do it? You just open this add, you just click this add symbol, and you can name it anything you want. I can name anything and I want. I can name SSH2 also, and the host port must be configured like this, and the guest port must be configured like this, but I already have this, so I'll just delete it and fine. So both this thing, one is host only adapter connection and the second is port forwarding is done. Now I will just go to my command prompt and here type this. Okay, so before that, we will just see what is our computer name. Our computer name is LG demo, right? You can see here. Fine. So I will go here and type SSH P2222 our port and then type LG demo at the rate localhost and it should give the connection right. It asks for the password. You say LG and here it is connected and ready for use, right? You can just type any command here, right? You can type echo something, echo hello, and it says hello. It works as a Ubuntu system now. Now what we did want to do, we wanted to run this command, right? ROS to launch project LG final launch dot py. But sadly, this doesn't do anything, and we don't understand why, right? So you can see here, no display name and no display environment variable. This is the problem. There is no display configured. How can we solve this? Fine, we will solve this. I will just stop the previous running system and how to solve this? We have to tell this command prompt, this command line that use this virtual machine desktop environment as the normal monitor, the normal display. Use the virtual machine display as your own display, your SSH display. How to do this? You have to just write export display colon equal to 0 and it will be configured. Okay, it is not okay. I just made a mistake. There is equal to colon 0 and it is exported. Now that you do the previous thing, you have to launch this project LG file, project LG launch file, and I'll just try to launch it again. ROS to launch project LG final launch dot py, and let's see what happens. You can see it starts here perfectly. So this is how you can control your SSH from a remote access, remote environment, and then use the virtual machine display as your own command line display and execute everything. We'll just stop this and stop here. That was it. Thank you.